Um, so like I said earlier to you guys, we are live streaming this up on YouTube right now for the first time. So I do apologize if there's any random things that occur or pop up while we're doing this. Just a little bit about what we do and who we are. So we're a coding boot camp. We have a single Python class. It's a 10-week full-time course. It's Monday through Friday, 9:30 to about 3:30, 4 o'clock. And throughout the 10 weeks, we build about 10, 12 projects, go through a lot of the programming concepts that require you to be a junior level to intermediate level developer. Basically, you can come in with no experience or experience in other languages, or even just experience in Python, and come out being able to build full-fledged applications with Python, right? What we tend to build is we use the Flask micro framework, which allows us to build web applications in Python. So over the course of the 10 weeks, you learn 5 different languages, 3 different frameworks, and if you guys want, there's pizza. All right, so thank you for coming to the event. Like I said earlier, the bathrooms are behind me, these 2 doors. We have pizza in the kitchen. Feel free to get up at any time. And then also drinks in the fridge, help yourself, and snacks by the elevator, also help yourself, right? So today, what we're pretty much going to be going over is just introductory Python. I'm going to be going over some basic level concepts, data types, variables, loops, functions. Well, actually, if we have time for functions, right? And then at the end, what we're going to do is we're going to create a little game, okay, a little guessing game where we'll have the computer generate a random number and we'll actually try to guess it, right? And it'll let us know if it's higher or lower within a certain range or a certain value point. If you guys do have any questions, one of our former students actually back there, her name is Sasha. Just raise your hand if you have trouble getting something to work, and she'll just come right over and help you guys. If you have any questions pertaining to the course itself, feel free to ask me. Just ask me afterwards. Just hold the questions until after, okay? I'm sure most of you have already met Kirsten, right? And then we also have the guy back there in that room. His name is Reepel. So the 3 of us will be here after and also during the break in the event. So if you do have any questions, please just hold them until then. So what we're going to do, the first thing is we just need to open up PyCharm to begin with, right? So go ahead and open up. It's called JetBrains PyCharm. I just call it PyCharm. All right, so open that up. And it should pop up at some point. There we go. Might take a little long. Okay, again, if you're on Anaconda or using Jupyter Notebook, the code is the exact same, right? So that's perfectly fine. You can follow along with the same code. Okay, so if you're using PyCharm, what we're going to do is we're going to create a new project, right? If you're using Jupyter Notebook, just create a new file. Okay, so open up Jupyter Notebook, launch it, and then go to new file. It should be Python 3. Okay, if you need a little bit of help opening that, feel free to raise your hand. All right, so for those of us that are on PyCharm, we're going to create a project, new project, and we're going to call this workshop. All right, I'm going to save it to my desktop. Feel free to save it to anywhere you guys would like to. And just hit create. All right, so it's going to set up some things for us. Basically, Python is a language where it needs an interpreter to run, right? Essentially, that's what it's creating for us. That's what this little creating virtual environment box is doing, is it's just downloading the interpreter in order for us to run this code, which could take a couple minutes. Well, a couple seconds. It's not that bad. All right, so once it's booted up, if it's not booted up just yet, I'll give you guys about a minute to let that catch up here. But what we want to do is we want to right click on this workshop folder up here. This is basically our project folder that we're starting with. We're going to right click it and we're going to go to new and click on Python file. Okay. Again, if you're in Jupyter Notebook, all you need to do is create a new file. You're good to go and just follow along in the code. All right, the name that we're going to give this is lesson_01. And click OK to create it. Right. I enlarged my screen, the text within it, as much as I could. I can go more. If you guys do have trouble seeing it back there, just let me know, okay? All right, so one of the first things that I always like doing is comments, okay? Usually what makes a difference between a good developer and a great developer is good commenting. Right, so in Python, in order to comment something, we actually use the hashtag, or if you're old enough, the #. Right, I'm used to both. So we're going to be writing a lot of comments throughout this, basically to just block off the sections that I go over each time here. If you're on Jupyter Notebook, you can actually just create a new cell, okay, for each different section. And that's perfectly fine. So I'm just going to put here, use hashtag to comment in Python, right? And this might just yell at me a little bit. One thing about PyCharm is it catches errors all the time, even if you know that there's not an error, right? It's a little annoying sometimes, but it's okay. Okay, so the first thing that we're going to go over is data types, right? So I'm going to just mark off a giant section, put a bunch of hashtags here, and put a header of data types. All right, just that way, if you're scrolling through, generally you can easily see that this is a brand new section over here, okay? So the first data type that we're going to talk about is integers. So I'm going to put a little comment here saying integers, a colon, and integers are whole numbers. Okay, so we have 0, 1, 2, 3, 4, 5, so on and so forth. Right, any whole number you can think of, that is basically an integer. Now, what we're going to do is we're just going to print one out right now, right? So this print with the parentheses, okay, is called a function. Now, we might have time to get into functions, we might not, but this is a built-in function that Python has that basically just outputs the code that we put inside of these parentheses here, okay? So if I want to just output an integer, all I'm going to put is any single number. So I'm just going to put 3. Right, and when we want to run this code in Jupyter Notebook, there's a little there should be a little button at the top that says run, or like an electric or a lightning bolt or something. For us on PyCharm, we're going to go up to run up here. Okay, up in the toolbar, click on run, and you should get this little box pop up. Okay, then we're going to click on the little arrow on the right of lesson 01. And you should have a terminal pop up on the bottom. Okay, our terminal is basically what's going to interpret and output the code for us right here. All right, so don't worry about the location. This is basically what's being run. So this is the file and the location of the file. Over here, it lets us know that the process finished with exit code 0, which means that everything worked out well, right? If it finished with exit code 1, that would mean that there was an error somewhere. But we can see that we did print out the number 3 here, right? So we could keep going on with printing out whole numbers, but these ones are pretty basic to get. So any whole number is an integer. The next data type that we're going to deal with is a float. Okay, and these are decimal point numbers. Right, so anything ending in a decimal point. 3.2, 4.1, 6.9, right, so on and so forth. And we're just going to print, I'll say 5.6 here. Okay, and in order to run the code now, we don't have to go up to run. You can go just to the right over here and hit this green run button. Okay, and so when we run that, we actually see that it still prints out the 3 because we're still running that statement, right? And then it prints out 5.6, which is our float variable. or rather data type. Okay, one thing you might notice, if you're not used to comments, or if you haven't seen commenting before, is that it's not printing anything out, right? The only things that are printing out are what we put inside of the parentheses within the print statement that we have going on here. And then also any comments there are, basically when it gets read, when the file gets read, it actually completely ignores anything in a comment, okay? So the next data type that we're going to go over is Booleans. Okay, and what Booleans are, I always like to think of them as switches. Right? There are either true or false values. Basically, think of a light switch, right? You either have it on or off. That's essentially what a Boolean variable is, or Boolean data type is, okay? It allows us to kind of track whether something has occurred or not. So what we're going to do is I'm going to print both Booleans here. I'm going to print true, and then on the next line, I'm going to print false. And we're just going to run that. Okay, so we can see that it did print out those two values as well. Right now, if we don't want them to be printing out, all we have to do is comment out any one of these print statements. So I'm actually going to go ahead and do that for just about every one of them. Now, I want to show you guys a shortcut here, though. Rather than going to each line and putting a hashtag right at the beginning, right? Nice little shortcut is if you press on Windows, it's Control /, which is where the question mark is. On Mac, it's Command /. If you just click on that line and press Control /, it'll automatically comment it out. Now, the reason why that's nice is what you can do with that is you can highlight both of these print statements and press Control / and it'll comment both of them out. So it's a nice little time saver if you ever need to do that, right? A lot of times when you're working with any code, really, you know, there's certain sections that you just need to comment out completely. You know, you don't want to delete them, but you also don't want them to run. So you just highlight them and you comment them out. So there's a nice little shortcut that we can use. So I'm just going to start commenting out each print statement as we, or right after we run it here. Okay, the one after that is called a string. These are essentially one or more characters. Okay, what I mean by a character is pretty much it also has to be within single. So let me just say within single or double quotes here. Okay, what I mean by one or more characters is it doesn't matter if it's a one, a number, a symbol, or an alphabetical character, right? As long as it is inside of two quotes, it's read in as a string value. Okay, so if we go ahead and we print, and I'm going to do both single quotes and double quotes, right? So if we put down single quotes and I say, this is a string, okay, and we run that, right, it's going to print out a nice sentence here saying this is a string. We can also do the same thing with double quotes. So I can say print and then put double quotes and say this is also a string. Right, it still prints out both of them the exact same way, okay? One thing to keep in mind here is the use of single or double quotes, though, okay? You can't mix them up. You either have to begin and end with single or begin and end with double, right? The nice thing is that we can actually use the opposite of whatever we used on the outsides inside of it. So if I wanted to say, you know, something with a concatenation like your, right? So we're going to print, and this time, though, I'm going to use double quotes. I'm going to print your, let's see, your programming skills are awesome. And then we're going to just run that code. Right, and notice that it's still printed out the single quote over here, right, for your. Okay, that works because we use double quotes on the outside. What won't work, though, is if I switch this to using single quotes here. Okay, you can already notice that PyCharm's actually pointing out a problem here, right? The fact that the rest of these letters aren't green, like all of the other ones that are supposed to be a string, lets me know that there's an error. And that's only because we have that single quote right there. Now, there is a way to get rid of that. If you just put a backslash in front of that single quote, it's called an escaping character, okay? So it basically realizes that this is part of the string and won't read it in as the ending single quote. Okay, it'll understand that it's actually part of the string itself. Okay, and then the last data type before we move on to the next section is my favorite and one that makes Python extremely powerful are lists. Okay, now a list is essentially a collection of any data type. Okay, now what I mean by that is that we have strings, we have booleans, we have integers, we have floats. There's other ones too. I'm not going to get into them. But what a list does is it actually allows you to hold all of those different elements into a single collection, right? So if you wanted to save, you know, say 1,000,000 numbers, but you didn't want to have to save them all into 1,000,000 different variables. We'll get into what variables are in a minute. You actually use a list. Okay, so lists are what makes Python powerful, in my opinion, because when you work with, data, large sets of data, you're really going to be working with lists here, okay, and libraries that Python uses the power of lists. And so when we get into looping and for loops, you'll also see how great lists are within Python. Okay, now in order to print out a list is actually defined by square brackets around it, right? So if you see square brackets, anything inside of those brackets are defined as an element inside of a single list. Okay, so we're going to put a couple elements here. I'm going to put the number 3. Then in order to separate each element, use a comma. Okay, so the number 3, we have a single element that is an integer. The next one, we're going to make a string. So I'm going to put single quotes and say string inside list. Okay, and then I'm going to let's put a float, so 4.5. And then let's also put a Boolean value, right? So false. And let's go ahead and run that. Okay, and actually, I'm just going to comment out the 3 print statements up here, right? You don't have to necessarily, but just for the sake of my own screen, I just want to keep it a little bit cleaner. So again, the shortcut, Control // right? It's a lifesaver sometimes. Okay, so if I rerun this, you'll notice that when it prints out, it actually prints out with the brackets around it, right? Now, remember, this is a collection of elements. So it didn't matter that all of the elements were different, okay? It holds it all the same. So that's pretty much the section for data types. The reason why I always start out with that, by the way, is because pretty much all programs are based off of the data types. If you've gone in other programming languages, right, then this is pretty much the same thing that you've seen. Maybe list is a little bit different. List in other languages would generally be called something called an array, right, especially in older languages. But it's pretty much the basis of any programming language that you use. So what we're going to do next is we're actually going to get into string manipulation. Okay, so I'm just going to put a little section here, little header, string manipulation. Oops. A nice little big header there for us to use. And what we're going to do is we're actually going to use built-in Python functions to start manipulating or changing around strings, right? So remember that data type string, it's within the quote. It's several or more characters. Basically allows us to print out sentences or words, right? So what we're going to do is I'm going to put a print statement here, and I'm just going to print out. Actually, let me put a comment here just to tell you guys which one we're using right here. So we're going to go over, this one will be splitting a string. So I'm going to say splitting a string by white space. Okay, so imagine that you had a giant string that had several words, but you wanted to do something to each word, right? First, you'd have to actually split it up. So if we have a string here, we'll just say we are working in PyCharm. Okay. After that ending single quote, we're actually going to call a function that strings can use. And the actual term for them is methods, but I don't want to confuse you guys too much. I'm not going to go too in depth to that, right? So this is going to be the split method that we have here. Okay, now similar to print, right? Anytime you see these parentheses, it's what we call a function, right? Basically, the parentheses calls that function, and that function tells you to do something. Okay, what our print function does is we put something inside of the parentheses, and it tells the program to print this out, to output it to the terminal. What we're about to do with split, okay, is we're going to put inside of those parentheses a single quote or single quotes with a space in the middle here, right? Make sure you put a space. This is basically going to break up this entire string into a list based on the white space or the space in between each word, okay? So if we go ahead and run this, I'm just going to comment out the other print statement on the list and run it, right? What we get is we actually get back a list, okay? It's a list of all of the words inside of it, right? That's what the split function allows us to do. Now with lists, we could then go through each element inside of here and do whatever we wanted to with them, right? And I could change it so that they have different endings or capitalize the first character in each one of them. And then we could put it back together. But this gives us flexibility to manipulate any sentence or words that we have here. And you don't have to just split on spaces. You can split on anything, right? If you know that things are separated by commas, right? Comma separated values, a CSV from Excel, you can actually split based on a comma, right? So we don't have any in here, so I'm not going to go over it. We're just going to go on to the next one. So this one's going to be replacing. All right, and I'm actually going to say replace the exclamation point with a period. Okay, and we're going to write our print statement out here. And we're going to put the same string that we have above. We're going to say we are working in PyCharm, exclamation point. Okay, I'm going to comment out the print statement above and just run this initially. Right, so nothing changed, obviously. We haven't done anything with it. We're just printing out the single string data type that we have here. Right, but we want to change it so that that exclamation point on the end actually prints out as a period. So what we're going to use is something called the replace method. So after that ending single quote, we're going to say replace and then put parentheses. Right, so remember, again, anytime you see these parentheses, it's a function call. So it's doing something specific. Right, inside of those parentheses, I'm going to put single quotes. We actually need to put two things, okay, separated by a comma. The first one is what we're going to replace. So I want to replace the exclamation point. Within that string, I put an exclamation point. Okay. Now, you can actually see on PyCharm, it's nice enough to give us kind of what this replace method is looking for. So we just put in the old string here, which was the exclamation point, and the new string that it's going to replace it with is going to be a string, but a period inside of it. Okay. Now, don't get too hung up right now on what methods or functions are. Okay. I'm just mentioning them because we're using them currently, but we will go into them a little bit later on and what they do and how they work. Essentially, right, they're just lines of code that do a specific task. So replace just has a couple lines of code that replaces one character passed in and replaces it with another character passed in. All right, so if I run this code now, we'll actually notice that when it prints out, that it removes the exclamation point there and inserts a period. Okay, so the next one that we're going to go on to is find the location of a certain character. Okay, now I'm going to print, and I'm just going to say looking for looking for a character. Okay, that's all we're going to put. I'm going to just comment out the print statement up above. Right, so sometimes when you're working with strings, you want to find a specific place, right? Now, it doesn't just have to be a single character. It could be an entire word. So what you have to use is after the ending single quote there, we're going to put dot find. And again, these are functions that we're calling, so we need these parentheses, right? Now, what I want to find is, let's look for the lowercase letter o, right? I want to find something at the beginning just so I can show you guys something important here. All right, so if we go ahead and in the string within those parentheses, we put o, okay, and we run this. Right, what I want you guys to note here is that the dot find method that we called, what it's going to do is it's going to print out the placement where the location of what we're trying to find is. Okay. Now I want you guys to note that number that was printed out, 1. Right? Why 1? If we look at the string here, we have an L and then we have an O. Right? With most programming languages, what this is referenced as is actually something called indexing. We're going to go over in a minute. But what I want you guys to notice is that indexing actually starts at 0 for just about every programming language. Not all, but most of them. Right? So when it found the O, right, if it starts at 0, which Python does, L is actually at the 0 position, right? Which means O is at the 1. And one thing to note on the find method here is it only finds the first instance of it. Okay, if you want to find multiple instances, you have to use a loop. And we'll get into that later. All right, the next one that we're going to go over, and it'll be the last one that we go over for string manipulation, is stripping white space from a string. Right, so the reason why this one's important is oftentimes when you either web scrape data or you get a giant file of data, that data usually is not clean. What I mean by that is that there's a lot of spaces, the words don't look right, things aren't separated well, right? So part of your job is actually to clean it up. Nice thing is that Python actually has a lot of built-in functions for us to use. One of them is this one, right? So if I write a string, I put a couple spaces in front, and I just put in the string stripping white space, and then put a couple spaces on the end, right? If I run this, okay, and actually I'm going to run it after I take out that upper print statement. If I run this, right, you'll notice that the string stripping white space actually was moved over. And the reason being is because there's white space in between the start of the string and where that first character is, right? Now, it's hard to see because it doesn't really show anything on the side over here. But if I highlight what got printed out, right, you can notice that it stops right after all of those spaces. Okay, so it does recognize the spacing on the right as well. We just can't see it. So if we want to get rid of that, we can actually use something called the dot strip method. And so we can just put dot strip here. Okay. Dot strip, if we run it now, actually completely strips the white space from the left side and the right side, right? Making our string value clean. So you can imagine if there's 1,000 records or rows that you have to go through, right? And hand editing that is just a nightmare. That's a very bad way of doing it. Instead, write a program that takes it in, just uses the strip method on it as it loops through, and you can do it in about 4 or 5 lines. Right. You can also, there's a couple other functions with strip. There's lstrip and rstrip, and basically it strips it from a side, right? So lstrip strips white space from the left, rstrip strips white space from the right. And it doesn't just have to be white space, by the way. If I have a bunch of W's, as sometimes that happens, you might get some weird symbols, okay? In the strip, I can actually put a string that basically says, hey, I want to strip all W's, okay? And if we run this, right, it gets rid of the W's. Now, just to show you that that actually works, if I don't pass into those parentheses into strip, okay, it'll actually print out with all the W's there, right? So that's just a nice little way for us to clean it up. I'm just going to put that W back. All right, so we're going on to the next section here, which is going to be one of the more important concepts in programming, and that's called variables. Okay, the reason being, or the reason why variables are so important is because it allows us to use information throughout the life of the program, right? What we were doing up above is just printing out data types, printing out strings, integers, floats. But what happens when you actually want to use those later on in the program, right? Well, what we were doing before, you can't. They're not saved anywhere. So that's where variables come in. So let's create our first variable here. Actually, I'm going to write a couple comments for you guys just so you can write them down and have them in this little lesson plan. We're just going to say variables are used to save information to be used later. Also, another comment, a variable can be of any data type. Okay, and the last one, a value is assigned to a variable name given. All right, so those are just little tidbits on variables here. Okay, so the first thing that we're going to do, I'll write a comment for it, is we're going to create an integer variable. And I'll go over the exact syntax after. Let's just write it out first. So I'm going to say x equals 5. Okay, and then I'm going to print x. And then let's run that code. Okay, what you'll notice that got printed out was actually the number 5. So let's start with the first line here. On the left side, we have a variable name. Okay, the name that we've given it is x. Now this is an arbitrary name. You can call it whatever you want, right? I can call it baseball. I can call it computer. It doesn't matter. However, later on in the program, that's how you have to reference it. Okay, so if I called that variable, mouse, I would then have to say print mouse, right? So when you're assigning a variable, you always have to follow it up with the name followed by the equals operator. Okay, now I say operator. In programming, plus, minus, times, divide, all of those symbols are called operators, right? So we'll be using those more. What this does for us is it's basically saying whatever's on the right side is a value that we're going to assign to the name on the left. So this is taking the number 5 and assigning it to x. Then on the second line here, we're using our print statement, and we're printing out x. So what the computer ends up doing is it says, okay, well, there's a variable called x, so do me a favor and go find it in memory and get me the value. Right, so it goes into the memory, grabs the value, and then says, okay, well, the value is 5, so let's print 5. And that's pretty much how variables work. Right, so for the rest of the time that we have this script, as long as that is not commented out, I can reference x anywhere in this file. So let's move on to creating a float variable. And we'll call this one y. And I'm going to give it a value of 3.3. And then we're going to print y. And I'm going to comment out the print x statement, but I'm actually going to leave x equals 5 in there, okay? And we'll notice that our floating point variable actually prints out, right? Because remember what happens. We assigned a name of y. The value to the right of it, 3.3, is what is assigned to it, right? When it's saved into memory, it basically says that there's a variable called y, a value given to it of 3.3. Now, the reason why variables are really important, I'm just going to comment out the print statement, is I'm going to say, just put a comment in here saying, use x and y to print, or rather to create a z value, which is the sum. Okay, so here's where variables are really important. If I want to save information on variables that were already saved, right? So I'm going to say z equals. We're going to assign the value of z, or a variable of z, and we're going to give it the value of x plus y. Okay, then let's print z. And run that code. Okay, so what it does is it actually prints out the sum of our x and our y variable. Now, the nice thing for us is that it doesn't just print it out, it actually saves it, okay? So funny enough, what I used to do back in college for my math homework is I would actually write programs to do it for me because it was actually really good practice, right? Good practice for programming, okay? Because what you can do is you can save those variables that you need to assign and then you use them later in a program. A lot of times what I tend to do is if you have a problem and you think programming can solve it, it's actually really good practice to try and program it out, right? That's why math is always good for it, right? Math problems, small ones. Okay, so again, we can now use the variable z anytime we want in this file. Now, the reason why that's nice is because let's say that I didn't know the value of x or y, right? If I took down some information, I pulled down some information, and we ended up saving it into a variable above, but I didn't know what it was, right? Being able to use these variable types that we have here, the variable saved, save them, or use them in, like an equation like we have here, is what allows us to make these programs. Okay, so we're going to move on to the next one. And I'm actually going to skip Booleans because Booleans are pretty easy, right? Actually, I'll write it out real quick. I'll just say Boolean, and we're going to save, we'll save it as switch, right? I usually like to save Boolean values as either switches or something called a flag, right? The flag's up or down. Think of a mailbox. If you have mail, right, you put the flag up. If you don't, you put it down. So we're just gonna say switch equals false. Okay, I'm just gonna comment out the print z here. Right, the big one though that I want you guys to really understand here is saving a list to a variable, right? So list as a variable. So I'm going to create a list called sports, right? Now your variable name should generally be something that is associated with the values, okay? I was using just random numbers up above, so I, just use x and y and z. They could be coordinates, right? If you do use coordinates, generally you'll use x, y, and z. For lists, you want to make sure that the variable name is something easy to read, right? Because later on, right down here, if I didn't know what that was, right, the list was, and I just wrote sports, okay, my assumption is that it is a list of sports, okay, or just a couple strings. But if we have z here, I might not know what it is, right? So it's always good practice to make sure that your variable names are relevant to the information that it's storing. So within this list, we're going to put a bunch of sports. I'm going to put baseball, football, basketball, and hockey. Okay, that way if we print sports here, right, it prints out the entire information that we need. Okay, now that leads us into our next section here, actually, which is called indexing, right? I mentioned it earlier a little bit. Okay, so I'm just going to put a couple comments here. One of them is going to be certain data types use indexing, like strings and lists. Indexing in Python always starts at 0. Okay, so we have that sports list that we had created up above, and it's actually printed out on the screen right now, which is good. But let's say that I don't want the entire list. I only want a single element out of it. Okay, we have to use something called indexing here. So if I want to just print out, let's say baseball, right? I'm going to write my print statement. And then in order to access information within this list, you got to remember it's a variable, right? So in order to access a variable's value, you have to first write its name. So up above, we just printed sports. So that's where we're going to start. We're going to start with print sports. For indexing, it's always the same way, okay? It's always the same syntax. And that's with square brackets, right? Anytime you see square brackets after a variable name, like this, right? Also works on strings. We are indexing here, okay? So an index is a number, it's a location. So if I want to print out baseball, remember, indexing always starts at 0. So we're just going to put the number 0 within those brackets there. I'm just going to put a comment above this that says print out baseball from sports list. Okay, and then we're going to run it. Right, I still have the print statement from up above working. I wanted to for now just to show you guys the difference here, right? So what we did was up above, we printed out the entire list, which printed out all of the elements. Then we used indexing to print out the very first element in the list, which is baseball. Now, what's nice about this is you can couple this with string manipulation, right? And then you can change anything you want about it. So imagine that you have a list of names that have white space and aren't capitalized properly. What you can do is you can actually, we'll get into loops a little bit, but you can run a loop based on a given index, and it'll actually do it all for you. It'll make a nice title case, strip all the white space, and it'll do it only at about 2 lines, 3 lines, right? So it makes your life easier. And it wouldn't matter if it was one person's name or a million people's names. Okay, so if I wanted to access football, basketball, or hockey, I would just have to type in 1, 2, or 3. Okay, now where you've got to be careful with indexing is indexing an element that's not there, right? Basically accessing an index out of range. So if I go to index 4, right, there are 4 elements here, but it starts at 0, so the last element's actually 3. If it tries to look for index 4, which does not exist in this list, and we run it, we actually run into an error. Okay, and it lets us know that the list is out of range here. Okay, so if you get that error list index out of range, then you can assume that whatever you're trying to index doesn't have something there. So I'm just going to put this back to sports 0. Okay, now we're going to write another comment here, and I'm actually going to just comment out that print statement and the one above for sports. And I'm going to say save basketball into a variable and print it out, right? So I'm just going to say Celtics equals. Now, if I want to assign an element from a list into a variable, right? We can actually do it the same way that we printed it out. So the first thing that we have to understand is what is the location, the index location of basketball? Well, if we start counting from the beginning, right? Baseball is element 0. The location is 0. Football is at 1, and basketball is actually at index 2. So we need to access the sports variable name at index 2 in order to access basketball, right? So if we go ahead and say sports bracket 2, and then we print Celtics, and we run it, okay? What we did there is we actually took an element from a list, a single element from a list, assigned it into another variable, and we used that variable throughout the rest of the program, which in this case is just a single print statement. Right, so when we get into like conditional statements, if statements in a little bit, what's going to basically happen is that we'll be able to loop through a list and we'll be able to check to see if it's something specific, right? So if it's a name or it's, it's title case, so the first letter is capitalized, right? If that happens, then we can assign it to a variable if we'd like and say, name equals this, and we can print out name. So variables just give us this extra flexibility, and indexing allows us to grab specific elements in specific locations. Now I'm just going to show you guys indexing on strings real quick as well. So I'm going to say indexing on strings, just because it's also good to remember that you can index a string, okay? Strings are based off of a 0 index as well. So if we write out a string called name and we have it equal to John Smith, okay, if I want to just print out J, we're going to say print. I'm just going to comment out the print statement above. And we're just going to say print name. Now, again, if I want to index, it's always the variable name followed by square brackets, right? And then inside of the square brackets is the index location. And if I want to print out just the beginning J, I would just say name 0. Okay, so if we run that, we actually just print out the single character J here. Okay, now I don't want to get too complicated, but just because this is an introduction into Python, but there are ways to print out JOHN specifically, okay? And just to show you guys really quickly, if you wanted to do that, you could put 0:4. Okay, and if we run that, what happens is that inside of this, right, this is basically saying print out the indexes at 0 all the way up to location 4. Okay, so I'm just going to set that back to 0 there, though. All right, so we're going to move on to the next section, which is going to be string concatenation. Okay, we get into a lot of the heavier stuff, if statements, loops, and then also the program at the end. We'll do that all after the break. We're going to take about a 5-minute break in about 10 minutes here, okay? So string concatenation is basically taking two strings and putting them together, right? So if we go ahead and we create a variable called first_name and have it set equal to the string John, and then last_name and have it equal to Smith. Right, I'm just going to put a comment right above saying take two variables and create a full name. Okay, now I want to print out a full name, but there's several ways to do it. That's the nice thing about Python is that there's multiple ways to get a single result. Okay. Now the first way, so I'm going to write a comment saying first way is to print out both variables. Right? Where we write a print statement here, and we're just going to say first_name, and we're going to put a plus here. Okay, and we're going to say plus last_name. Right, so this is basically going to add the two values of these variables together. So it's going to take John and add it with Smith. So when we go ahead and print this out, we run it. Right, let me just comment out the print statement above. And we run it, we actually get the value John Smith. Now, it's actually, if you guys notice what it printed out, is John Smith, but combined without a space, right? Now that's because the program did exactly what we've told it to, right? Computers are smart, but they follow instructions to a T. So what we did here is we took first name and added last name to it, but we didn't add any spacing in between it, right? And there's no spacing in those variable values. So right after first name, we're going to put another plus, and then we're going to put a string with a single space inside of it. Okay, so single space inside here. Now let's go ahead and print it out. All right, now it prints out John Smith properly. Okay, the second way to do this, so the second way is to assign both into a single variable. Right? And so we're going to create a variable that makes sense for one, right? The naming convention should be proper. So we're going to say full underscore name equals first underscore name plus, and don't forget that space in there. So plus a space plus last underscore name, right? So now for the rest of this program, all I have to do is say print full name. And if we run it, I'm going to comment out the top print statement here. If we go ahead and run it, we actually print out the exact same thing that we did above, except this time, right, I have the ability to access John Smith as a full name, as a full string within this full name variable. And now up above, we had assigned a variable called Celtics, and we made the value basketball. So what we're going to do is print out a nice string statement. And we're going to say print, and I'm going to put a string that says the Celtics play, and then I'm going to leave it at that, right? Play what? Well, within this print statement, you can still concatenate, right? So we're going to say plus Celtics, because remember up above we had assigned this variable Celtics to be the word basketball. So if we go ahead and run that, I'm just going to comment out this print statement. We run that, it actually goes ahead and says a full string or full sentence. It says the Celtics play basketball. Okay. Now the reason why that's important is because for any team, right, if I wanted to write out all 30, I think there's 30 teams in the NBA, right? If I wanted to write out all of the teams, essentially what I'd have to do is, write out 30 print statements. There's way easier ways to do that, okay? And we'll get into that a little bit later. But the nice thing is that I don't ever have to write the word basketball again because it's assigned to Celtics. All right, now the next thing that we're going to do is probably one of the most important concepts in this section is a formatting statement, okay? So I'm going to just put a comment that says Python formatting for strings. This will inject variables into a specific location. Okay, so one thing I want to do first is I just want to show you how you could put multiple variables within a single print statement here, right? So I'm going to say print in a string that says my name is, and then a space, and then plus first underscore name, and then plus. We're going to put another string. Actually, you know what? Let's change that to the original one. We'll say first name colon. The next one will say space last name colon. And then we're going to put on the end of that one plus last underscore name. Okay, if we run that, what we'll actually get back, okay, is a full sentence that does say first name John, last name Smith, right? But if you look at this print statement, it gets a little tougher to read, okay, because it's not a full string, it's not a full sentence. It has variables concatenated in the middle of them, right? Now, I know this is, not terrible to read, right? But imagine you want to input 5 or 6 variables within a large string, okay? It gets a little worse as you get into bigger programs. So the real way to actually go ahead and do this is to use a format function, okay? So if we write print, and then I say first name, colon, I put a space, but then I go ahead and I put curly brackets in, okay? And then I put another space, and I say last name, colon, and then I put curly brackets in again. Okay, you'll see what these curly brackets do in a second. After the ending single quote here, we're going to say dot format. Okay, and again, we've seen them before with the string manipulation that this is a method, right? And we're calling this method here. So what is going to be passed in is actually the variables that we want to put into the locations of these curly brackets, right? So this is basically allowing us to write out a full string and then inject the variables wherever we see fit. So within the format parentheses is actually where we're going to put the variables, the same ones from the previous line, right? First name and last name. So we're going to write in first underscore name, comma, last underscore name. And we're going to run it. Okay, so that looks much, much cleaner. It's way easier to read this string right here than to try and read that one with all the variables in the middle of it. Right, and if we wanted to make the last name look a little bit nicer on the next line, we could actually put an escaping new line character if we put a backslash and an N. Okay, that's a little HTML trick that you can see in most programming languages. You'll see that in print statements here. Just all it does is assigns a new line, right? So the same thing as hitting enter. Okay, that way it just prints it out nice and neat. But now it's easy to read. So the way the format function works, okay, is it takes the variables that were passed in inside of the parentheses for that call, and it maps them to the subsequent curly brackets, right? So first name goes into the very first set of curly brackets. So it goes over here into this one. Last name goes into the second set, into these curly brackets here. Right? If I had accidentally reversed the variables, so I put last name here and first name here, right? Last name would actually go into the incorrect placement here into those curly brackets. So make sure your variables are in the correct order when you write your format statements. Okay, so that pretty much covers the beginning hour of this portion of the class. We're going to take about a 5-minute break. Feel free to use the restroom, grab water or any drink out of the fridge. There's pizza, there's snacks near the elevator. Please help yourselves. When we come back, we're going to be going over if statements, which are branching statements that allow us to basically create a way for us to check conditions, okay, do something based off of it. Then we're going to go over loops, right? And loops are one of the essential concepts in programming, okay? After that, we'll then go into a mini game. And if anybody would like to stay after, I can show, or I can go a little bit into functions, but we'll see what time we have after those three, right? So feel free to take a quick break. And I'm just going to turn the lights on for the time being. All right, guys. So I'm just going to comment out this print statement, and we're going to move on to the next section here. So I'm going to write in this little big block. And the header that we're going to put here is conditional statements. Okay, and they allow us to run code based off of a certain condition met. Right. So think of your own decisions, your own decision making, right? your brain, will come into, what should I eat for breakfast, right? Am I hungry? Am I not hungry? That type of thing. Well, programming does the exact same thing, but we use if statements to do so, okay? So we're going to write our first if statement here, and then I'm going to go over the syntax afterwards. So what I just want to say is let's assign a variable called name, and we're going to have it equal to John, okay? Then I'm going to write an if statement. Actually, rather than using strings, we'll use numbers. I'm going to define x equal to 3 and y equal to 5. And I'm going to write an if statement here that says if x is less than y, put a colon and then hit enter. Print, we're going to print a string that just says x is less than y. Okay, and then we're going to run that. I'll explain what's going on here in a second. Okay, now if you're coming from another programming language, this stuff isn't new to you guys. Probably just the syntax is different here. Okay. But it is an introduction workshop, so I'll be going over the essentials, the syntax, everything. So when we look at this statement here, the very first line, or the very first 2 lines here, we're just declaring variables, right? So I'm creating a variable x with a value of 3 and a variable y with a value of 5. Now, the next line here is this if statement. So this if keyword is required. Okay, in Python it's required if you want to type an if statement or create an if statement. You put if first, right? After if is actually followed by your condition that you want to check, right? So I'm basically checking to see if the value of x is less than the value of y, right? And then the colon here is required for syntax purposes as well, right? After that, we hit enter, and we come down to the second line. Now, what you'll notice here is that there's a huge space, okay? So in most programming, or some programming languages, a lot of older ones, blocks of code are actually sectioned off by curly brackets, okay? That's, I've worked in C and C++ before, that's how they are, right? But in Python, it's actually indentation oriented, which is actually really nice because I'm very particular about my indentation levels, especially when creating websites in HTML and CSS. I want to make sure that they're all lined up properly. So it's actually nice visually. So in Python, it's either 4 spaces or a single tab. I always suggest use tabs, okay? Spaces get a little tough to see. If it's 1 space off, it breaks the computer. Not the computer, but it doesn't run the program, okay? So it won't work. So you got to be careful about that. So just always use tabs. Each tab indentation level, okay? So this is 1 tab indentation level in, okay? Each indentation means that there is a new block. Now, these blocks are associated with certain statements. So one statement is a conditional statement. That's the if statement that we have here. For every if, you always have to have a block, okay? And inside of that block are an arbitrary number of lines of code that you can write. And if that statement proves true, which x is less than y, it will run that, which is why it ran our print statement here, okay? Other reasons for having an indentation of a block is when we get into loops and functions. So the next thing that we're going to do, though, is we're going to go over else statements. Start with else, and then we'll go over to elif. Okay, so if we essentially want to have this if statement run if x is less than y, but if it's not less than y, right, we want to do something completely different, we need to use either an elif or an else. So I'm going to go over what else statements are first, right? Else statements are the keyword else. And you can see keywords based on how they glow, right? Print is a function. If and else are keywords. So we put the keyword else followed by a colon, right? That's correct, proper syntax here. And then we hit enter, and we can see that there's a new indentation block. So we're just going to print, and we're going to say x is not less than y. Okay, and we're going to run this. Now, the reason why this actually still prints out x is less than y, right, is because what happens with an if statement, right, anytime you use else after it, that else is associated with the if, okay? So if one condition is met, it is not hit. So this if condition here is still true, right? X is still less than y. So it still prints this, but it doesn't run anything else. Once it meets a certain condition in one if statement, it's done with that entire block, okay? And else is associated with that if. Now, the way else works, the reason why we don't have a condition after else is because it runs no matter what if it's hit, right? So if that one condition doesn't get hit, else will always get hit. So if we put x equal to 7 this time, and we run it, okay, we actually print out x is not less than y. Because what it did is it goes line by line, right? The interpreter reads from the top, bottom, and the left to the right. So it declares these variables, checks the print statement, or checks the condition on the if, right? It realizes that x is not less than y. So what this does is it actually returns false, right? It's not true. It's not less than it. So it says you can't run this block of code on this if statement, and it moves down to the next one, right? And down to the else. Okay, and since there's an else there, remember, if an else gets hit, no matter what happens, it will run the code inside of it. Okay, now one thing I just want to point out is that if I comment those out, okay, so that means that else in the print won't get read in. It doesn't even exist to the interpreter. And I run this, right, nothing is printed out. Okay, because this condition isn't met, this print statement doesn't run. Okay, so I'm just going to comment that back in. Now, the next thing that we're going to go into is something called an elif statement, right? What happens when, you want to check to see if something is less than, see if x is less than y, but I also want to check to see if x is equal to y, right? Because if it's equal to it, I want to print out that it's the exact same value. So what you need to do is you need to write an elif statement. So you start by writing the elif keyword here, and then you write a condition. All elifs need a condition, okay? So if statements need a condition, elifs need a condition, but the else does not, because the else just says, if you get to this point, run whatever is in the block of code. So we're going to say elif x is equal to y. Okay, and I'm going to print, I'll get back to the elif in a second. I'm going to print the values are the same. Okay, and we're going to set x equal to 5 here. And before I run the block of code, I just want to point out one thing. Notice in the elif statement that we have two equals operators here, right? In Python, when you see two equals operators, it's based on a condition, okay? It's comparing something. If you see one equals operator, it's assigning, okay? It's assigning a value. So for variables up here, we see one equals operator, it's assigning that value to it. But for this elif, there's two. It's checking a given condition. It's checking to see if the value of x is the same as the value of y, right? So if we run the code now, right, we actually get the print statement. The values are the same. The reason why that works, right, remember, is it checks the first if statement, okay? And it realizes that this is false, x is not less than y. So it doesn't even do anything with this block of code. Moves on to the next elif statement, and it checks to see if that condition is true, which it is, right? 5 is equal to 5. So it goes ahead and runs this block of code. Now, when it's done with this, so right after it prints, it doesn't care about anything underneath it, right? One big thing to take away here is that you can have as many elif statements as you want. You can only have one if, and you can only have one else. But the elifs and the elses are required to have and be connected with a single if, right? So I can have 20 if statements, but I can't have 20 else statements without an if, right? And all elifs, again, same as else, have to be connected to an if. So what we're going to do here is write elif x greater than y, and we're going to print x is greater than y. Okay, I'm just going to change x back to 7 here, and we're going to run it. So remember, it tries to find the given condition that is met, and once it does, it runs that block of code, but not anything else. Okay, so that's why it runs this one where x is greater than y, and it prints it out nice and neat for us. Okay, for the most part, we've covered all the basis of less than or equal to or greater than. So that else statement probably won't get hit. There's a certain couple of conditions where it could get hit, where if you're not comparing numbers. But again, that depends, and that's a little bit more advanced. But for the most part, you can set up as many elifs as you want, right? So it's one if, as many elifs, one else. Now, they don't always require an elif or an else, okay? Oftentimes, it's just a single if statement. But it's just dependent on what kind of program you're trying to write or what kind of task you're trying to create. Okay, I just want to go over one other way to use an if statement here. If we go ahead and we create a flag variable, okay, which I usually set to Boolean data types, a flag, remember, on or off. I'm going to set this equal to true. Okay, and I'm going to write a if condition here that says if flag, and I'm going to put a colon. And I'll go over what this means in a second. And we're going to print out the flag is true. All right, and I'm just going to comment out all of the code above here, all the if statements, just so it doesn't print out any of that. And then we're going to run this. Okay, now you might be thinking, how did this work? There's no condition here, right? You're just putting in the variable name. You're saying if flag. How does that work? If you just put in a variable name, okay, or some sort of just single word, it's basically checking to see if it's true, right? I don't have to put, or I could put, I don't need to, but I could put equal true, like so, okay? If I run it, it still runs perfectly fine. However, and PyCharm's actually yelling at me about it, is that it says the expression can be simplified, right? Which means that I can put it back to what I had before, which is saying if flag. Okay, so this is just checking to see if the variable type that I have in here is true, which it is because we just said it before it. If it's false or anything else, okay? So if it's false, then it's not going to run. Okay, funny enough, what you can do to actually make it so it's opposite, right? And this is getting a little complicated, but I just want to show you guys a little trick, is if you put the keyword not after if, it reverses what that value is, okay? So you're basically saying if not false, or rather if not true, which means that if the flag is false, okay? So it's the opposite. And if we run this, it'll actually say the flag is true, which is incorrect, okay? So we would have to change this to the flag is false in order for this to be proper. Right? So that not keyword just kind of reverses true or false. I'm just going to put a little comment up above it. It says not reverses value to opposite. Okay, with commenting, there's a way to do good commenting and bad commenting. You can very well over-comment your code. Comments should be short, concise, and descriptive. It's harder to do than you think. But you can always tell good comments, right? Anytime you're writing, by the way, you're writing a program, always just comment. Make sure you leave comments for yourself, even if you're the only one that's ever going to read it. Too many times have I ever worked on a project myself, come back 3 weeks later, and had no idea what I wrote, right? It happens all the time. Okay, so we're going to now talk about and/or statements within conditionals. Okay, so if I wanted to base something off of two conditions, right? or I wanted to check two conditions, and I wanted to see if one of them was true. That's where the and or keywords come in, right? So let's just set some values here, basically saying x equals 5, y equals 3. That's fine. Okay, and what we're going to say here is I'm going to say if x is less than 10 and y is less than 5, colon, print. We'll just say print this worked. Okay, and we'll run it. I'm just going to comment out the print statements above. Okay, so the print statement, this worked hit. Now the reason being is that this and keyword here is the important piece, right? It's the new thing that we're just going over. What it's basically saying is it's looking at the expression on the left side and the expression on the right side, and is basically saying that both of these need to be true, right? If you want to run this block of code, both of them need to be true. So it needs to have x as a value less than 10 and y as a value less than 5 for this to work, right? If x is equal to 11 and we run this code, and actually let's put an else in here. So I'm going to say else print it did not work. And we're going to run it. It prints out it did not work. Now the reason being, again, is because and looks at the left side and the right side, and both conditions need to be true. But here one of them is not, right? X is not less than 10. So that is false. So I always have a little chart, and basically it says for and statements, true and true is true, right? Anything else is always false. Okay, so before we had true on the left and true on the right. This time we have false on the left and true on the right, but that still is a false. Okay, so that if statement won't run. Now to basically have that run, right? If I want to make sure that it runs if either of these is true, right? So true and false, or false and true. If either of them are correct, okay, we're going to put or. Okay, that's where or comes into play. Right, so your or statement is going to check to make sure one of them on the left or the right is true. So out of the three ways to get this to work, right, basically saying that true on the left or true on the right works, true on the left or false on the right works, false on the left or true on the right works. But if both of them are false, then this does not work. Okay, so if I said y equals 6, right, it's going to run it did not work because this statement will be checked and will come back false, and then this statement will be checked and will also come back false. So if both of them come back false, the or doesn't matter, it's false. Okay, which means that this does not run. Well, this runs. This block of code runs, but this does not. Okay, and you can even mix them in the same line. It doesn't have to be just and or. You can also say and here, and then give another condition. Okay. One thing with that is just be careful of the order of operations. Sometimes an and will get hit before an or, right? So what you should always do is if you want one place or one thing to specifically run, oops, throw parentheses around it, right? So if I want to check that this condition gets checked first before the and condition over here, right? So I'm just going to say over here, this will be, this makes sure that specifically it will check this first because it's within the parentheses, right? If I put parentheses around the y and the and over here, okay, it's going to check those conditions first. And based on what you put, it could give you a different answer, right? So if you're mixing ors and and statements into it, use parentheses. But I don't want to get too complicated in here. So I'm just going to leave it at just using an and an or. And I'm going to comment these out. Okay, so we're going to move on to the next section. Okay, and actually before we get into loops, I want to do one thing because it's going to make our programs a lot more fun here, right? I'm going to take in user input. So we're going to call this section user input. All right, this is going to allow us to basically include the user into our programs. We're going to take in whatever they want to, you know, in our term, or in our case, we're going to create a game where they guess, right? So we're going to take in a number that they guess, and we're going to spit back out some information to them. So in order to do that, first thing you have to do is you have to save it into a variable, right? Because when they put in input and they hit enter, it needs to go somewhere in order for you to use it again. That would be where a variable comes in. So I'm going to always call this ants. It's always going to be short for answer, right? You know, when you get into programming, you have short variable terms that you generally associate with certain things. I always associate ants with input because I'm expecting an answer from them. So on the right side, we actually use a keyword called input. Okay, well, it's actually a function call. So within this input function call, we're going to put a string, and I'm just going to say, what is your name, question mark. Okay, and then I'm just going to print, and we're going to make a nice formatted print statement here, right? So I'm going to say, hello there, blank, exclamation point, right? And when I say blank, I'm just used to it. I mean curly brackets, right? Because in a format, remember, curly brackets means that we're injecting a variable into that position, right? Using the dot format method here. Okay, and so what we want to put in these parentheses right here is actually the input. Now, if we look at the line above, the input's actually being saved into a variable called ants. So we're just going to put ants here. Okay, and so when we run this code, right, one thing to note is that you're going to need to come down into terminal and click in it, and then you can type. But you'll also see that the program didn't end because it didn't give us an execution of 0 anywhere, right? So it's still running right now. So what we have to do, we have to go down and click in the terminal down here, and I'm going to put in, you know, a name. So I'm going to say John Smith, and then hit enter. So what it does is it saves it into our variable after it inputs, right? So that's here. We type something in, and it saves it into ants, right? And then we write a nice print statement down here where we inject the ants variable into our curly brackets. All right, now there's a lot of different things that you can do with that. Let's go ahead, and I'm just going to comment out both of these lines. Feel free to also do the same, because otherwise the next time you run, it's going to ask you this again, okay? And I don't want it to ask me what my name is again. All right, so I'm just going to say, again, ants equals input, and I'm going to just put in, what is your favorite number, question mark. And we're going to print, your favorite number is blank, curly brackets, right? We're going to put dot format at the end of the string and say ants. And we're going to print this out. So when it comes down here, I put 9. Your favorite number is 9, right? So it spits out the number. Now, one thing you got to be really, really careful about here is you have to understand the variable, or rather the data types that you're working with, okay? Because depending on what you're checking, it's vital, or it could break your program. Okay, so let's write an if statement to say if your number is less than 10. So I'm going to say if ants less than 10, colon, I'm going to write a print statement. Okay, otherwise, so else, I'm going to print your number is greater than 10. Okay, so PyCharm actually sees the problem, right? So what I want you guys to kind of see right here real quick is if I type in a number, okay, what's going to happen is the number is going to be typed in perfectly fine, right? We see it as a number. However, the way the computer takes it in for input is always going to be a string, okay? And you can't compare a string as a number. It doesn't work like that. So what you have to do is you actually have to convert the string that you take in, right? As long as you are expecting a number, right? So if I'm asking for a number in return, then we can convert it into a number from a string. Now, in order to do that, we have to do something called type converting, right? And so I'm just going to put a comment up above here that says, use type converting to convert a variable into a different type. Right, so the way it works is if we go ahead and actually declare ants equal to int ants, right? If we run this, which I will in a second, I just want to go over real quick. What's going on here is that it's asking for input. So it takes in a number, but you got to remember that it's taking it as a string. So what we do in the very next line is this right here, this int and then parentheses is actually what we call type converting. What it does is it's going to change the data type from a string to a number, right? That way Python can actually run a calculation on it or a condition based off of a number, right? Which we are checking. Okay, this way this doesn't create an issue. What might create an issue though is if you actually type in a word. Okay, so that is actually where you can shore up your program with something called try and accept, but that's an advanced topic that we won't go into. Okay, so this way, if we run the application now, right, what is your favorite number? 9. Okay, this time it actually printed out your favorite number is 9. So the comparison or the condition actually was able to be checked this time, and it checked and saw that 9 is less than 10, so it ran our print statement here. Okay, if I run it and I put 11, okay, it should say your number is greater than 10, which it does. Okay, so you got to be very careful of the data types that you're working with here. So I'm just going to comment this stuff out. Feel free to do the same. And we're going to move on to the next section here, which is loops. Okay. Now, whether you know it or not, you've come across more loops than you can count. Okay, every single program, well, almost every single program has a loop, and it's usually something called a main loop, right? The main game loop. Now, the concept of loops is essentially think of something waiting to end, but continually running until it needs to, right? Let's take a game, for instance. There is a loop that is created when you start a game, and it's basically, you know, it depends on what game you're playing. If you're playing a shooter, then it's basically going to play until your health is 0, right? Or you beat the level. So there's conditions, and it's going to keep running code until those conditions are met, right? So we have 2 different loops that we can use. We have a for loop, which is generally used for counting, right? So if I ask you to count to 10, you're going to go 1, 2, 3, 4, 5, right? Well, with us, or with programming, what you can use is you can use a for loop to count it. So rather than me printing 1, printing 2, printing 3, right, writing 10 different lines, we can actually go ahead and write a for loop that will count up for us and print out every single number. So that's what we're going to start by doing. Okay, I'm going to say use for loop to count to 10. I'm going to write it up first, and then we'll go over the syntax. I'm going to say for I in range 10, print I. Okay, and then just go ahead and run the program. Okay, what you'll notice is the output actually counts from 0 up to 10. Okay, it goes from 0 to 9. Right, it prints out 10 numbers. We could change that, but again, that's probably for another day. What I want to go over here, though, is how this for loop is working. Right, so this loops will always continue to run based on a condition. Right, remember that. This for loop is running until it gets to 10. Okay, that's the condition that's being met here, right? So range is actually a function and it's counting default from 0 up 1 each time. Okay, you can change those. If you want to count by 2 each time, you can. But this is counting up to 10. And once 10's hit, okay, it checks that condition's met, and it gets out of the loop, right? It stops. If I say count to 1,000,000, it'll do it. Might break eventually, but it would do it. Okay, so what we have going on here for syntax is it always starts with a for keyword here, right? So you always have to put for. The next thing after that is actually the character I. Now, this is where things get a little confusing, okay? I actually is essentially, it can be any name, right? You can say num, you can say I, you can say j, you can say anything there, okay? It's kind of like a variable name because that's exactly what it is we'll see here that we're printing I, right? Well, what happens in a for loop when you're using the range function is as it counts up, each iteration, right, each time through the loop, I actually gets assigned to whatever the current number that range spits out. So range starts at 0, so it spits out 0 and assigns I to 0, right? And again, this name can be anything. It can be I, it can be num, right? It doesn't matter. The reason why it does matter, or where it matters, is rather in the block of code, okay? So I access I here. That's where we print out the number, right? So the first iteration through I is 0, we print out 0. The next iteration through I is 1, we print out 1, right? What's incrementing the value, okay, is the range function. Okay, that's doing a lot of the work for us right now. So I say iteration. All that means, if you're not familiar with it, is just that each time we go through the loop. So it hits this for keyword, or this for line right here, right? And it says, okay, loop until this condition is met, so start a range, so start a counter. Initializes I to 0, comes into the block of code, and runs all of this code, right? If there was 1,000 lines here, it would run 1,000 lines once, right? And then it would stop and go back up to the top of the loop, and it would increment I. So it would go up to 1, right? Then it would run all of these lines in here again, right? Each one of those is an iteration. So it goes back up to the top and keeps doing it until the number is met. And our number that we ask it to meet is 10, okay? So for loops are really good for counting, okay? Counting purposes, or counting to something. The other reason that for loops are really powerful is using a for loop with a list. Okay, so we're going to define a list called sports, and it's going to be equal to the same thing that we had above, which actually I don't even know if we have to assign it because it should be. There we go. So I'm going to comment out the for loop, and if I just print out sports real quick, I think it was assigned up above. Yep. So again, that's the beauty of variables. We had declared it above. I don't ever have to worry about declaring it again, right? I just need to access sports. So if we go ahead and write a loop and say for sport in sports, colon, print sport. And then let's run that. Okay, this is actually one of the reasons that lists are so powerful, is because you can write a simple for loop within just a couple of words, right? In older languages, you would have to, a for loop actually gets a little bit bigger. Not that it's a nuisance, but it's much, much longer. The same for loop, I probably have to write about this much code, okay? Again, that's why I always enjoy Python, is it's less code, and it does essentially the same thing. It's powerful enough. So what's happening here is that we're basically saying that the condition it needs to loop to is the end of the list, right? So for sport in sports, it finds out how many elements are in there, and it says, okay, there's 4 elements in there, so I need you to loop up to the number 4, right? So as it loops, instead of assigning a number, though, with a list, it actually assigns the value at that index. So in the first time through, it works on the very first element, right, which is baseball. And so inside of this code, we print out sport, right? We could do anything with sport. Sport is baseball in the first iteration, and we could, basically write an if statement that says, if this is baseball, print you're starting a 9-inning game or something like that, But the next time through, okay, this sport think of it as a temporary variable, right? This sport right here actually gets assigned as the next element, which is football. And then it prints football out, right? It goes up to the for loop and restarts again. It assigns sport into the next element, which is basketball, and so on and so forth. These two lines right here, written as is, if that list was 1,000,000 elements long, would still print all 1,000,000 elements just with those 6 words, right? It's really, really nice to be able to do that. And especially with inside of Python, you always work a lot with data, right? So we could manipulate the data here. And just to give you guys an example, if we wanted to, make all of the sports lowercase and print them out, or, we could check an if statement. So if I said if sport is equal to baseball, right, print, the season starts soon, exclamation point, right? Else, just print the sport. Okay, if we run this, okay, it's going to go through all of the elements, and it's going to run this block of code here. Okay, so remember the indentation levels. The for has an indentation level. This if also has another indentation level. So this block of code where this print statement is associated with the if. This block of code where the print sport is associated with the else. And then this if and else block here is associated with the for loop. Okay. So that allows us to do specific things based on the elements that we loop through in this list here. Okay, now we could also manipulate the sport here. So if I said print sport dot lower and put parentheses around after lower, okay, and we run it, right? Notice that before it was capital F, capital B, and capital H, right? Without having to go through each element, we can just manipulate it right in line right there, right with the for loop as we're looping through. Now, one thing this doesn't do though is it's only printing it out. It's not saving that that value as that element again, right? So if I print out sports again here and I run it, okay, sports is still saved as all capital, right, or all title case here. So you just got to keep that in mind. If you want to change those specifically, there is a way to do it. It's based on the index, right? Which actually is the other way to use a for loop. So if I'm going to comment these out first. Okay, and we're going to comment that just says loop through list using index, alter list itself. Okay, so in the for loop up above here, right, I altered the string sport, but remember, it didn't alter the list itself. It didn't alter the elements inside of the list. Because that sport temporary variable that was created, again, was a temporary variable, right? So we weren't altering the elements directly. We were altering a temporary variable that held a similar value. So if we go ahead and write for I in range, okay, I'm going to introduce another function here called len. And then we're going to put sports. Okay, and I'll go over this in a second. Inside of here, though, we're going to say, let's just print first, and then we'll adjust it. Okay, I'm going to say print sports bracket. I'm going to say I. Okay, and I'll go over that, the reason for that in a second. If we print this out, right, this for loop, what it's doing is it's basically doing the same thing as for sport and sports. Okay, except this time we're printing it out based off of an index. Now, the reason why that's important to keep in mind is that now when we alter the values, because we're altering the index itself, we're actually altering the original element value, right? So what's going on here is len sports. This function finds the length of the list, right? So the length of the sports list, there's 4 elements inside of it. So the length is 4. Okay. If you guys remember the range function, right? We said range 10 earlier. It counts up to it, but it doesn't include that number, right? So if we're saying range 4, it's going to count 0, 1, 2, 3. Right? So for each iteration, the first one, I is going to be equal to 0, right? And if you guys remember indexing, what happens is you If you want to index a list, you use the variable name followed by square brackets, and then inside of the square brackets is the index number that you want to access, right? So I0, or when I is equal to 0, right, that's sports bracket 0, which is actually the very first element in the list, which is baseball, right? So that's why it prints out baseball first. Then this code finishes and it goes back up to the for loop and increments I by 1. So I is now 1. So this becomes sports bracket 1, right? Which at that location is football. And it keeps doing that and doing that over and over again. But this time, let's go ahead and not just print sports I, but let's alter it above the print statement. So I'm going to put a comment in here that says alter element directly, right? I'm going to just set it to lowercase. Okay, so we're going to say, sports bracket I. Okay, remember when assigning variables, or rather assigning values, what you need to do is you need to put on the left side the name, the variable name, right? On the right side, I'm going to put an equal sign. I'm going to assign this to sports I dot lower. And now I know it's going to look confusing at first. I'll go over it. And let's just run it. Okay, and then if we print sports at the bottom again, this time it's actually altered the elements inside of the list directly, right? Whereas what we did before did not. Okay, so if you want to alter elements, you have to use a specific for loop here. So what this line right here is doing, okay, when you work with variables, you put a variable name on the left and you put the value on the right. When you're working with elements inside of a list, if you want to alter that list element specifically, okay, if I want to change hockey to soccer, I would basically access, right? I'd have to access the third index in this list and then assign it a value different than hockey. Okay, that's basically what we're doing in this line right here. Okay, at sport 0, so at this index right here, have it equal to the same string, so have it equal to baseball, but lowercase. Okay, that's what it's essentially doing, right? The key here is the I, right? The I variable, that temporary variable that's being used as we loop, right? So in the first iteration, it's 0. So it's saying sports 0 equals sports 0 dot lower, okay? Which is taking baseball with a capital B, turning it to lower, and then actually resetting that value at that index. Okay, and just to show you guys that specific, I'm just going to put a comment that says change hockey to soccer. Right? And if we want to do that, I basically have to access the third index. So I'm saying sports bracket 3, and I have to assign it to a different value here. So I say equals, and then the string soccer. Right? That way, when I print out sports afterwards, it actually prints out with the string soccer replacing hockey here, right? Because we actually altered what was at that location specifically. That's why that works, right? Okay, now the next loop that we're going to go over is a while loop. I actually am just going to like kind of section this off a little bit, a little mini one. All right, so I'm going to say while loops are good for conditionals. All right, what I mean by that is usually a while loop is going to be associated with looping until something is true or looping until something is false, right? So think about, again, first-person shooter. I always go back to games because it's an easy reference point. Think about why you would use a while loop. Well, you want to run the game until the character either has 0 health or beats the level, right? So that would look something like while character health greater than 0 and, game over does not equal true, right? Then run all of this code, and it would continue to run and run and run. So what I'm going to do is I'm going to set a flag here. I'm going to set the flag to false. Okay, and we're just basically going to say while flag equal to false. Okay, now PyCharm's going to yell at me a little bit, basically say that I can condense this statement down. And if you guys remember what I did earlier, the if flag meant true, but this time we're doing false, right? So I'd have to write if not flag. Okay, right? It's the opposite. I'm going to leave it as this just for the time being. So just ignore the little squiggly lines for now. But we're going to say while flag equals false, print hello there, exclamation point. Actually, you know what? We'll introduce user input here as well. Okay, so I'm going to say ants equals input, and I'm just going to say type quit to stop playing, colon. Right, and all I'm going to say, I'm going to check a condition to see if ants equals quit. Right, so I'm going to say if ants is equal to not quit, the word quit, but the string quit. Okay, so the string quit is different than the word quit. So we put the string quit, colon. If that happens, then we say print thanks for playing, exclamation point, and we change flag equal to true. Okay, let's also add in an else statement here. So else print you typed colon. I'm going to put a couple curly brackets format, and we're going to put in ants. Okay, so let's think about this for a second before we actually run the code. Let's think what happens here, right? So the first thing we do is we set a Boolean variable type to false, right? So it hits the while. The while is going to check to see if the flag is false first, right? If that flag was set to true, it'll never run the while loop, right? Because flag was always true, so it doesn't even hit it. But while flag is always equal to false, okay, it's going to run this entire block of code over and over and over. And then the only way to break out of that loop is by typing in quit. And when that happens, right, we actually declare the flag to be changed to the value true, right? So what happens is, let's run through and say that they actually typed in quit the first time, right? So we set a flag to false, the while loop hits the condition and says, this is true, so let's run the code, right? We input, or we ask for input, we say type quit to stop playing. They type in quit, right? And so what happens is this statement actually becomes true. And so it prints thanks for playing, changes the flag to true, and it'll keep running down here, right? Keep running the block of code. If there's more lines of code down here, it's still going to run it, right? It's going to run everything in this block of code until it gets back up and it checks that condition one more time, right? Now, because we set flag to true, this time it doesn't run it. It stops the loop. So let's run the code now and see it work. All right. And if you accidentally didn't comment out the print statements like I did here, I'm just going to type quit right away. And we should see that it just says thanks for playing and stops right away. Okay. Let me just comment out the print statements above. Okay. Come back down to the while loop and run this. And every time I put in some gibberish, right, it lets me know what I typed. Okay, and it's going to keep doing that until I type quit. Okay, once I type quit, it says thanks for playing. So in programming terms, I always like to call this the base case, right? So I'm going to put a little comment that says base case right above the if ant equals quit. This basically says that when you design a loop, okay, you have to have a way of getting out of it, right? A way to get out of that matrix that you just created. So this is the base case to be set so that if they do type something in that we want to break out of, that it does actually work, okay? Now, one thing you got to be careful with in loops is infinite loops, right? They are a programmer's nightmare. The only infinite loop I will show you guys is basically if we go ahead, okay, and change this while flag equals false to just while true. Okay, don't run that yet because it's an infinite loop, right? While true essentially says just keep running the code, never stop. The only way to stop this code from running and in order to break out of it is actually to write a break statement, right? So rather than setting flag equal true here, we actually would just write the keyword break. Now what this does is it breaks out of the current loop. So if it's inside of a while loop, it'll break out of it, right? If we wrote a for loop and it counted up to 10, but we said if you get to 5, break out, right? It would stop counting at 5 and just end the loop right away. So if we run this and I type quit, it stops, right? So that's the other way that you can run this. Now, it's usually frowned upon to do a while true loop, but as long as you know what you're doing and you set a base case for small applications, it's fine. Okay. Generally, you'll see a ton of loops, right? If you create a program, even, software running until you hit the X button, right? That's a huge loop. It's just continually running the software until you quit. So loops are essential to programming here. Okay, so what we're going to do now is actually take everything that we just learned, data types, variables, input, lists, and loops, and we're going to create a game, right? A little guessing game. So I'm going to put a bunch of comments here. I'm just going to say fun guessing game, and then several other comments. Okay, so I'm just going to put a little description of the game. And we're going to say generate a random number, ask the user to guess this number. If the user is too high or too low, let them know. If the user guesses correctly, end the game and say congrats. Okay. So oftentimes when you're writing either a function, a script, larger programs, right? You write something out to keep track of what you're trying to do, right? A flow chart of some sort or a project proposal. Okay. Here is our project proposal for our very small game. Okay. So these are the tasks that we need to create. That's why you see me use the keyword if, right? I know that basically I have to write a condition for this statement right here. Right? I'm going to check to see if the number that they put in is higher or lower. So the first thing that we're going to do is I'm actually going to show you guys how to import a package that's built into Python, right? So we're going to say import random. Okay, now what that does is actually there's a file called random.py that has pre-built functionality into it, right? Which there's a function that generates a random number for us, so that every time we run this code, it actually gives us back a different number. So that's the reason why we're going to import this module here, right? Now modules are a little bit more advanced of the topic. I don't want to go into it too much, but that's the gist of it, right? We're just grabbing some other code that somebody else wrote, and we're using it for ourselves. What we're going to do is we're going to assign num equal to random.randint and put in the parentheses 0, 100. And if PyCharm just yells at you a little bit, we can see that the error, it's not a problem, right? But it's basically telling you that your import statement should be above. Okay, your imports actually should always be at the top of the file. However, for the sake of this lesson plan, I want it in line with the game. Okay, so it's at the top of the game, and that's perfectly fine. So the next line that we used was num. We're assigning a variable num, and what we're assigning to it is a value, a random integer here. Okay, that's what that means, random integer, from 0 to 100. Right? So that is a pre-built function inside of this file here that we're going to use, right? So somebody created that code, and it just spits back a random number for us. So from here, the first thing I always want to do is just print out the number, right? I want to see what the computer created. So if we hit play, oh, I have to stop the while loop up above. If you didn't comment out the while loop, by the way, that's going to occur, right? So just type out quit, and I'm just going to comment out that while loop from above and press play again, right? So if you keep pressing play, 54, 64, your numbers are going to be different than mine, by the way, right? It's going to give back a random number. Now we're going to use this random number so that we have the user guess. Okay. So we're going to put while. And actually what we're going to say is we're going to create right above it. Okay, actually right above the print statement. No, right above the while statement is what we'll do. Put a comment that just says create Boolean, or rather bool, called guest. Right, so we're going to call it guest, and it's going to be equal to false, right? Remember what I said about variable names? They should be associated with what you're trying to do, right? Once they guess the correct number, I'm going to change that variable, okay? So we are going to use the shortened version of this condition. I'm going to say while not guessed, okay? Which basically means while guessed is false. So while it hasn't been guessed properly, the first thing that we want to do is actually ask them what they want to guess, okay? So we're going to say ants equals input. We're going to say guess a number, colon. Okay, now, again, if we're working with numbers, we have to be specific, which means the variable or the data type has to be an integer. So we have to type convert it. So I'm going to say type convert answer, right? So we're going to say ants equals int ants. Now, one thing I do want to show you guys is that that can be shortened. And anytime you can get rid of lines of code and condense them to less lines, usually better. Not always, but usually, right? This is the same thing here as actually just wrapping an int around the input. Okay, so I'm actually going to write a comment above that and say ask for a number, then type convert to an integer. Okay, so we just did those two lines into one. Easier for us, or easier for the program. For beginners, it's harder to read though, right? So you got to be careful. If you're more comfortable with the other way, just write it the other way, right? Unless you're working with millions of records of data, it's really not that big of a deal right now, right? When you get into larger applications, then it can be. Okay, and so what we're going to do is we're going to check to see if ants, okay, now remember that we already type converted it, so we don't have to do that. So if ants is equal to num, right? Remember num is the number that was randomly generated. Then we want to print you guessed correctly, exclamation point. And then we want to switch guessed to true. So guessed equals true. Okay, if they don't guess it right, we basically want to tell them if it's higher or lower, right? So I'm going to put an elif statement saying elif ants is greater than num. We want to print the number is lower, exclamation point. Okay, we don't want to change guess because they didn't guess it. And we want to write another elif saying ants less than num. We want to print out the number is greater. Right? I actually don't need to put an else statement here because it's really going to be one of these three. Okay, if we get any other answer, generally you want to make sure that random inputs are okay to work with. So if somebody puts in a string, right, a word. So if they literally put in a word, not a number, then when this goes to convert it, you're going to run into a problem, right? So that brings up an advanced topic called tries and accepts, which I'm not going to talk about today, but I can point you in the right direction if you'd like to learn more about it, okay? It basically means that if the program tries to break, or if you try a piece of code and it breaks, it's not going to break the program. It's just going to do something else, right? That's where an exception occurs. So if they guess the number correctly, we change it, we print correct, right? So this is pretty much most of the program yet. Our while loop is just going to continually ask them and continually tell them based on their answer. So let's actually go ahead and run this. Now, the first thing I always want to do, I always want to check that my base case is there, right? So I print out the number just to make sure that I can guess it right away. So let's type out whatever the number is on your computer. So I'm going to type out 56 and hit enter. Right, so it lets me know that I guessed correctly. It changes guess to true, and it gets out of the loop, right? But let's try and guess, a number that we don't know. So I know the number is 39, but if I put in 45, it should tell me that the number is lower, right? And it asks again. So it says, guess a number, 23. The number is greater, right? So it's working. And then if I guess the proper number, 39, then it lets me know that I guessed correctly. So the base functionality of this game is actually working, right? So this is working code right here. Now let's add a little bit of fun into it, and let's calculate how many guesses we have. So we're going to keep track of the number of guesses. So I'm going to come up and right below num, I'm going to say track the number of guesses. I'm going to set guesses equal to 0. Now this is just an integer, right? The variable type that we have here is just an integer. But as we guess, I'm just going to increment it by 1. Right? So every time we ask a question, we then just say guesses equal plus equals 1, right? So add 1 to it. And one thing I want you guys to keep in mind is where are we creating these variables up, the variables that we're using for this while loop, right? The guess. If I put guess inside of the while loop, okay, we'd actually run into an error because it wasn't created before it. If I put num, okay, inside of the while loop, it would, think about what num is equal to. It's equal to a randomly generated number. If it is inside of the while loop, every time that line of code hits, it's going to randomly generate another number, right? I don't want that. I want it to keep one number and allow me to continue to guess that number, right? Same thing with guesses. If we set guesses inside of the while loop and we set it to 0, every time it comes back up to that iteration, it's going to reset it back to 0. So when we set it outside of the while loop, just above it, when we change the value of it inside the while loop, it actually keeps it. Okay, it keeps the value. So right after we ask them a number, we're going to I'm going to write a comment that says increment guesses. And we're going to put guesses plus equals 1, which just means that it's going to add 1 to it, right? So the first time around, we ask the question, increments guesses. And let's actually print out how many guesses they have, right? So right here, I'm just going to print right below guesses. I'm going to say you have tried, or you have guessed blank. Okay, remember your curly brackets because we're going to do a dot format here, blank times. And so we're going to do a dot format and pass in guesses. I do apologize for running a little bit late, but we're done. We're going to be done here in just a couple minutes. Right, so this is basically going to print out how many guesses we have. What's tracking the guesses, remember, is our guesses variable. And every time they guess, the next line, we increment it, right? So they guess, we increment, we print out the number of times. Then we check to see if they guess correctly, or we say number is lower or greater, okay? And so what happens is that the if ants equals num, we want to say you guessed correctly, and then let's also say print, it took blank tries. We're going to put a dot format here and also pass in guesses. So then if we go ahead and run the code, right? I know the number is 98, but if I guess 33, it lets me know I've guessed one time. The number is greater, so 45. Okay, the number is greater, 78, right, 98. Okay, and eventually I guess it correctly, and it took me 4 tries. Okay, now if you want to have a little bit more fun, don't print out the number, right? So don't go up to print num and comment it out, and good luck. All right, so there's a little trick actually to basically guess every single time under 7 tries. So just a little programming trick here is if you have the number every single time, and you can find out higher or lower, you can basically guess 7 or less times every single time. So if I say 50, you've guessed one time, the number is lower. All right, well, it's lower, so half that, 25. Number is greater, half of that, 37. Number is greater, half of that, 44. Number is greater, 47. Okay, 5 times. All right, so that's a little programming trick. It's a funny little mind game that you can play with people. All right, so if you say, let me guess a number between 0 and 1 million, and you give me 100 tries, you could probably get it within 100 tries. Okay. That's pretty much the lesson plan that I had for you guys for today. I appreciate all you guys for coming out. Anybody online as well. I believe that this will be hosted online for you guys to check out if you want to go back onto it. If you do have any questions for me based on the class, I'll be here for a little while. Feel free to ask. If you have any questions, if you really want to get into the class and know more information about, the next steps, Kirsten and Regal, the 2 back there, would be the people to talk to, right? So again, the class is 10 weeks. It's a full-time course, but you learn 5 languages, 3 frameworks, you build projects the entire time we're in there, right? We help you build your portfolio. And at the end, we have an entire week dedicated to just bringing in companies and you guys doing interviews with them, right? So we call it Showcase Week. And then after that, we still work with you guys until you get a job, right? So that's, pretty much everything that we do. We teach you guys basically come in as, I've seen people without programming experience. I've seen people with computer science degrees, right? And what I can tell you is that it's not about where you start. It's about how hard you work, right? The person that's going to work harder, if I don't assign homework or anything like that, is the person that's going to succeed more. Okay. So again, thank you guys for coming in. I really appreciate it.
Thank you.